Now I want to talk about lapse rates because lapse rates are very important and they're very useful in real world meteorological situations. So a lapse rate is simply just a rate of change of temperature with altitude. And there's really no fixed lapse rate in the real world. However, your book will tell you that the normal lapse rate or the average lapse rate is 6.5 degrees Celsius per kilometer, and that's what's known as the normal lapse rate, also known as the environmental lapse rate. Now, we're going to talk a little bit more about lapse rates later on in the semester, but I thought I would show you how to calculate lapse rates and why they are useful. So, knowing what a lapse rate is, let's for a second draw a diagram. So, if we say that this here is the surface, I'm going to just call it SFC for short, okay? And let's say our temperature at the surface is about 30 degrees Celsius. That's about 80 degrees Fahrenheit. And let's say that the top of the atmosphere, or some layer here, let's say we want to figure out the temperature for some layer of the atmosphere. Let's call it 2 kilometers. Okay? So this right here is 2 kilometers up in the atmosphere. The temperature is 30 degrees at the surface, and we know that the lapse rate is 6.5 degrees Celsius per 1 kilometer. So how do we figure out the temperature at the 2 kilometer mark in the atmosphere? Well, we simply just do a little bit of math. So if we know that temperature changes every 6.5 degrees Celsius per 1 kilometer, we know that if we go 2 kilometers, that temperature is not going to change once, it's going to change twice. So you can do 6.5 times 2, and that gives you 13. So that we know that temperature is now going to change 13 degrees from the surface all the way up to 2 kilometers. All right? So now let's just clean this up real quick. Here's the surface, and we know that temperature is 30 degrees here, and we want to figure out the temperature here at 2 kilometers. So all we have to do, we know what the lapse rate is, and we know that temperature is going to change. We'll call this delta. That's a way in the science community to denote change. So the change in temperature we know is going to be 13 degrees. And you know that temperature should decrease the higher that we go up in altitude. So temperature here at 2 kilometers is going to be equal to the temperature at the surface minus 13 degrees. So that means that the temperature at 2 kilometers is actually 17 degrees Celsius. And that would be the answer here. So this is a way that you can use lapse rates. Now, let's say we wanted to do it the other way. So let's say that we knew the temperature aloft, and we say that the temperature at 2 kilometers, or whatever it is, let's say the temperature at 2 kilometers was 15 degrees Celsius, and we wanted to know the temperature at the surface here. So we know that the temperature at the surface, right, we know that the lapse rate is going to change 6.5 degrees Celsius per kilometer. And if this is 2 kilometers, right, the distance between the top of the atmosphere, or this section of the atmosphere, to the surface, we know that temperature is going to change, what, 13 degrees. We just did this. So the temperature at the surface, right, is just 15 plus, we're adding because we're going towards the surface of the earth where it's warming, 15 plus 13, which is what? 28 degrees Celsius. Okay? So that's how we figure out lapse rates using some very simple mathematics. And this is very useful, especially when I teach you how to use this in later chapters throughout this semester. But for right now, keep it as simple as that.